Welcome. In this video, I'll be walking through my 2.8 RPN calculator. I'll be walking through the design, purpose, and development process of my reverse Polish notation, or RPN calculator. This project combines hardware and software to create a fully functional device capable of performing basic arithmetic using stack-based logic. The calculator uses a 16 by 2 LCD screen to display the inputs and outputs. Inputs are received through a one-wire analog keypad with 16 buttons, along with resistors to allow each button to produce a unique voltage. These voltages are interpreted using a threshold pin, allowing all keys to be read through a single analog pin, or the output pin. Once an analog voltage has been read by the Arduino then goes through the array of thresholds, finds which threshold matches with the read threshold, and then uses that to mirror into the keys array, which contains all letters and operators. The first step for any input is to be placed into the current input array. This array holds all inputs before the enter sign. Once enter has been pressed, the entire character array gets turned into a float that can be used for processing and display. Once enough operands have been placed onto the stack and an operator is hit, the code then pops the top two operands off the stack, placing them into float A and float B variables. It then creates a float answer, or res, or result, and then runs through a switch function that goes through 4 cases on which operator is pressed and does the subsequent operator on the 2 operands. It then makes res the answer of these 2 operands. Once all operands and operators are used, the DTO string format function takes the answer and turns it back into a character array. The 0 indicates the minimum size, the 6 indicates the decimal size, and the buffer equals the array it's going into, or the buff character array. This array is then used to print on the LCD screen. The final important part of the calculator is its error messages. Error messages are crucial to anything that has a user interface, because error messages tell the user how to use it and when they've done something wrong. In this example, it says stack empty. This means that the user tried to press an operator before there are any operands in the stack. This obviously can happen, so an error message pops up, stack empty. The next error is need 2 vals or need 2 values. This is when the user has put 1 operand into the stack but not 2, and you need to do 6 minus 6, not 6 minus nothing. So this also produces an error. In stack empty, you need at least 2 more operands, and in need 2 vals, you need at least 1 more operand.